Today's topic is Earth Station. So, in the previous sessions, I have told what is a satellite, what is a microwave link, what are the advantages of microwave link and disadvantages of microwave link, and what are the advantages of satellite communication, and what are the disadvantages of satellite communication. I have told about the advantages of satellite communication over the terrestrial communication. Okay, so I have told what is an types of satellites. Basically, based on signal processing, it is going to be classified into active satellite and passive satellite, and based on the height, it is divisioned into geosynchronous satellite and non-synchronous satellite, and based on purpose, it is classified into communication satellites and observatory satellites, and based on the area of working, it is divisioned into DOMSAT, that is domestic satellite, and international telecommunication satellite. So first of all, what is a satellite? That means it is a microwave link repeater that will revolving around the earth. That means it will receive the signals from the transmitting earth station and amplify these signals down converted, and it is send these signals to the receiving earth stations. So that is an satellite. Nothing but it is a body which will be revolving around the larger body. Okay, so in our solar system, moon is an natural satellite. Okay, so this is about the satellite. And whenever we are using the satellite, we are having the communication satellites. So in the communication satellites, the main part or the heart of the communication satellite is going to be transponders. That means the main work which is going to be done in the satellite is going to be transponders. So internal part of the satellite, it is going to be transponder, and the transponders are going to be classified into three types, that is single conversion transponder and double conversion transponder. So when we are having the transponder, what it does, that means it is nothing but an transmitter and receiver combination in a satellite is going to be known as transponder. Okay, so it will acting as an RF repeater. Okay, so typically we are having the 12 or 24 or more than that, it is going to be there in our satellite. So what is the main function of transponder means, which will be receiving the uplink signals from the transmitting earth station, and it is amplifying the received signal, and it is going to be translate them into the downlink frequency, and again it is going to be amplified, and these downlink signals are going to be transmitted to the receiving earth station. So this can be done with the help of transponder. So in these transponders, it is basically based on the configuration, that is based on the structure of the transponders, it is going to be classified into three parts, that is single conversion transponder and double conversion transponder and regenerative transponder. So in the single conversion, why we are going to be calling means, it is going to be translated only single time, that is the process can be done only once. So within the satellite, the frequency translation is going to be done, is going to be in single process. That's why it is going to be calling as single conversion transponder. And the next one is double conversion transponder. So in this, the name already indicates that it is doing the 2 times process. That means the translation is going to be done in 2 times. So that's why it is going to be calling as double conversion transponder. And the third one is regenerative type. So when we are having the regenerative type, it is nothing but when we are using the single conversion and double conversion, in that we are not going to have any differentiation between the transmitter and receiver section. So in order to differentiate that, we are going to be using the regenerative type. Okay, so it will sees that whether where the transmitter section is going to be ending and where the receiver section is going to be ending. So like that, it can be done within the regenerative parts. So this is about the internal working of satellites. That means the main part of satellite, when we receive some signals, it is having an internal process. So in this session, I am going to deal with the earth station. Why? Because I have said that the transponder will be receiving the uplink frequencies. That means where it is going to be received means from the earth stations. Okay, so what is an earth station, what it does, so what are the blocks which are going to be having in the earth station. That means how we are going to be getting the uplink frequencies towards the satellite. So when it is going to be coming towards the satellite, the transponder will respond and the transponder will do some process. Okay, so we are only in the previous session we have seen whatever the process is going to be done in the transponder. We are not having any idea about the earth station. That means on the earth's curvature we are going to be having an earth station and what are the main blocks involved in the earth station. So in this session I am going to deal with the block diagram of earth station and I am going to explain the each block of the earth station. Okay, so this is an block diagram of earth station. So in the earth station, initially why we are going to use the earth station means it is used to transmit the information towards the satellite, and not only with that, it is also receiving the information from the satellite. Why? Because whenever we are having the transmission of signals, we are transmitting the signals or data in the form of voice, whatever it may be, so which in the form of 6 gigahertz of frequency of signals, and whenever we are downlink signals are going to be received that are in the ranges of 4 gigahertz of frequency ranges. So like this we are going to be having the earth station work. That means it will transmit the information to the satellite, at the same time it will also receive the information from the satellite. So basically our earth station consisting of various subsystems. What are that means? They are ground communication equipment, that is GCE. You can see this, okay, GCE, that is ground communication equipment. And the next one is transmit subsystem. Okay, so we are having transmit subsystem, that means it is having the transmission section. And the third one is antenna subsystem, which is used for our transmitting of signals, at the same time receiving of the signals. And in order to have the processing of receiving signals, we are having the receiver subsystem also. And the main important of the block is going to be power subsystem. Why? Because for any communication equipments or any processing equipment or electronic equipment, it requires an power. Why? Because without of the power the process cannot be done. So for that it is main block diagram under the earth station, that is a main block under the earth station. That means the earth station can be divided into number of blocks, that is antenna subsystem, receive subsystem, GCE subsystem, transmit subsystem, okay, and the last one is power subsystem. Okay, these are the blocks which are coming with the earth station. That means the general block diagram is like this. Okay, so what is an ground communication equipment? So what it does? So in the ground communication equipment, it is having the transmitter, at the same time receiver. Two parts, it is divided into two parts. Okay, so what it does means, in this transmitter the baseband signals, that is TV signals or telephone signals, whatever with the data which is having to transmit, thus baseband signals are going to be multiplexed, and then it is going to be the multiplex output is going to be given to the modulator, and it is going to be modulated by the modulator, and that is going to be given to the next session, that is for the transmit subsystem. Okay, so that means in the ground communication equipment, it is division into two parts, it is transmitter and receiver. In this you can see this figure. So see, this is an receiver section, this is an transmitter section. So in this section, when we are having some baseband signals that are going to be multiplexed with the multiplexer, and it is going to be given for the modulator, which will modulate the signals with the help of carrier oscillator. So in this session, this is the output of the modulator is going to be given to this transmit subsystem. Okay, so this is about the transmitter section, and at the same time GCE receiver, that is this one, this will having the, in this process it is going to be having modulation, and in this the opposite of the transmit section. Why? Because already we have well known about the communication subsystems. Whenever we are having the modulation section in our transmitter, the receiver section is going to be having the opposite of modulation, that is demodulation is going to be seen in this receiver section. So like this, in this also we are going to be using demux instead of mux. Why? Because in this we are going to be using multiplexing, so you have to get some original signal, means we have to demux, and in this we are having modulator section, and in this we are having the demodulated section. Okay, so it is used for demodulating and demultiplexing of the received signals. So by this we can having this ground communication equipment. Okay, both are having the two sections, that is transmitter section and receiver section. The transmitter section is nothing but an original signal, that is baseband signal, which is to be transmitted, that are going to be multiplexed, and the multiplexed output is going to be given to the modulator, and it is going to be modulation is going to be done, and it is going to be given for transmit subsystem. And the receiver also, the opposite of the transmit section is nothing but an, whenever we are using the modulator in the modulator and multiplexer in the transmitter section, the opposite of that is nothing but an demultiplexing and demodulator. Okay, like this we are going to be using the ground communication equipment. Okay, that is the first section in the earth station. Okay, and the next one is transmit subsystem, so which is consisting of up converter, combiner, power amplifier and BPF, that is band pass filter. Not only with that, we are also having the HPA, that is high pass amplifier. Okay, high, no, it is not a high power, it is so in this section we are having the local oscillator, up converter, combiner, driver, BPF, and it is having the high power amplifier. Okay, so in this session, so what is the use of, means whenever we are having the up converter, what it does, it is increasing the frequency level of the input signal. So whenever we are having the modulator, that is going to be given for up converter, and which will be increasing the signal strength. Okay, that means which is going to be converted to a frequency. The modulated signals are going to be up converted, that is IF to the RF. Okay, so the up converted output is going to be fed to the combiner, and it will combine the different RF signals into one RF signal, and then it is going to be amplified by using the power amplifier, and then it is going to be transmitted to the satellite through by using the antenna subsystem. That means whenever we are having the transmitter section in the GCE, so that will be having the original signals, and it is going to be modulated, and that signals are going to be given for up converter, and this up converter is going to be doing the IF signals towards the RF signals. So it is going to be converting that IF signals to the radio frequency signals, and that output is going to be given for the combiner. So what is the use of combiner, means it combines the different RF signals into one RF signals. Okay, just like a multiplexer. Okay, so like this it is going to be getting one RF signals, and then it is going to be amplified by high power amplifier, and that is going to be given for band pass filter. What is the use of band pass filter, means it is just allowing the frequency which is stable with our system, and it will reject that another frequencies which are not in within this satellite. So like that it can be passing them or wanted signals, and it is going to be rejecting the unwanted frequencies, and it is also eliminates the harmonics which are going to be present in our signals. So like this we are going to be using with the transmit subsystem. So the next one is antenna subsystem. So what is the use of antenna subsystem, means the RF signal from the transmit subsystem is going to be applied to the antenna subsystem, and the antenna subsystem including duplexer that will be permits the use of the same antenna for both transmission and reception. Okay, so that means the antenna subsystem is having the originally antenna and with the help of a switching network calling as duplexer. So that means already I have told that the what is a duplexer means which is acting as a single pole double through switch. That means it is going to be connecting the antenna section towards the transmitting section, or else it is going to be transmitted it is going to be connecting to the receiving section also. Okay, so that means it is a single pole double through switch. Okay, it will acting as a single pole double through switch. Okay, so in this all earth stations have the large parabolic dish antennas that is going to be used for sending the signals towards the satellites and receiving the signals from the satellite. Why? Because whenever we are using the antennas, what type of antennas is going to be used means we are going to be using large parabolic dish antennas. Okay, so how much of length is going to be there means the earth stations will be using dishes means that is 80 to 100 feet or more in diameter. So it can be seen with the diameter sections. Okay, so with the help of diameter we can say what is the length of that antenna. Okay, so these antennas are always pointed to the satellite for transmitting and receiving the signals with a high gain. That's why it is going to be used within the antenna subsystem. That means the antenna subsystem receives the signals from the transmit subsystem and it is going to be given for duplexer. What is the use of duplexer means which will be acting as a single pole double through switch and it is permitting the use of same antenna for both transmission and reception. So usually whenever we are having the antenna subsystem, all the earth stations will are using the parabolic dish antennas mainly for sending the signals towards the satellite and receiving the signals from the satellite. So why we are going to be used means it is having some huge high gain antennas. Okay, so for that we are going to be choosing this dish antennas. So whenever we are having the height or whenever we are having some distance we can say as in the diameter. So that is 80 to 100 feet or more than diameter is going to be used as a dish antenna for the earth stations. So why it is nothing but which is having some high gain. And the next one is receive subsystem. So what is the use of receive subsystem means which consisting of BPF, that is band pass filter, and the next session is low noise amplifier, and the third one is power divider, and the fourth one is down converter. That means BPF, low noise amplifier, power divider and down converter. So what is the purpose of this means it is to amplify the received downlink signals from the satellite and to protect the receiver from the high power signals. So in this section what it does means the power divider divides the received signal into the multiple signals with equal power levels. So in order to have an power division equally we are going to be using the power divider, and then it is going to be down converted to our RF signals into our IF signals. Why? Because I have already told that in the all of the receiver sections directly the RF signals are not processed. Why? Because it is very hard to process that RF signals. So instead of that we are going to be converting into IF signals, and after that it is going to be converted to RF signals to have a original signals. So in this GCE the IF signals are demonitored and demultiplexed as necessary to generate the original baseband signal. So we can get the original signals from the receiver subsystem. And the last one is power subsystem. Okay, so most of the any communication systems like that which will have some power requirement from AC sources. Okay, so in this also we are going to be using the power supplies which will convert the AC into DC voltages required to operate all of the subsystems which are appeared in this. So, and not only with that, we are having the backup power system also, which will consisting of a diesel engine driving AC generator, which will takes over it and is a AC power failure. And when the AC power fails, an automatic system starts the diesel engine, and the smaller system may use UPS, which drives their main power from batteries. That means instead of if any problems are there within the power, so power backup is very needed. So for that reasons we are having an AC generator which will having do this problem. Okay, that means which can be overcome with the help of generator to have the power to all the subsystem which are present in our station. That is the most important subsystem in our earth station. So this is about the earth station block diagram I have explained. So let us have a brief explanation of that. So the main function of the basic function of the earth station are, it will transmit the information to the satellite and it will receive the information from the satellite. So the earth station consisting of various subsystems, they are GCE, that is ground communication equipment, and the next is transmit subsystem, and third one is antenna subsystem, and the fourth one is receive subsystem, and the last one is power subsystem. Next, so what is the use of ground communication equipment, which consisting of two sections, that is GCE transmitter and a GCE receiver. So in the GCE transmitter, what it does means the baseband signals, which are nothing but an original data, TV signals, telephones, whatever it may be, that are going to be multiplexed, and then it is going to be the multiplex output is going to be given for the modulator, which will modulate our signals. Okay, and what is the use of GCE receiver means, it is used for demodulating and demultiplexing the received signals, and it is going to be converting into the original signals which is going to be observed by us. Okay, so that is the use of GCE receiver. And what is the use of transmit subsystem? So the baseband signals are going to be modulated in GCE transmitter and are applied to the transmit subsection. In this, here the modulator signals are going to be up converted, that is IF frequency of signals is going to be converted to RF signals of frequencies, and the up converter output is going to be fed to the combiner, and then it is going to be amplified by using the power amplifier, that is high power amplifier, that is HPA, shortcutly we can calling as HPA. Okay, and then it is going to be transmitted to the satellite through by using the antenna subsystem. So this is the main use of transmit subsystem. And what is the use of combiner means, which will combining the different RF signals into the one RF signal. Okay, so that is the use of transmit subsystem. And the next one is antenna subsystem. So what is the use of antenna subsystem means, the RF signal from the transmit subsystem is going to be applied to antenna subsystem, and the antenna subsystem usually includes a duplexer that will permitting the use of same antenna for both transmission and reception. That means in the previous sessions also I have told that what is a duplexer means, it is a switch, it acts as a switch, that means single pole double through switch, which is used to connect the both stations towards the antenna. That means it can having the probability of getting the connection of transmitter section towards the antenna, at the same time it is having the probability to connect the antenna towards the receiver section. It is doing the two works. Okay, so that's why it is going to be calling as single pole double through switch. And next is the receive subsystem. In the receiver subsystem, which consisting of BPF, low noise amplifier, power divider, down converter. Okay, these are the sections under the receiver subsystem. So which will using the amplifying the received downlink signals from the satellite to protect our receiver from the high signals. In this session, what it does means, the power divider divides the received signal into the multiple signals, with the signal into the multiple signals with equal power levels. That means whenever it is going to be division the signals, that multiple signals is having the equal power levels, not with the unequal power levels. So then it is going to be given for the down converter, and this down converter is going to be converting the RF signals into the IF signals. So that is the use of receiver subsystem. That means it is used to amplify the received downlink signals from the satellite, and it will protect the receiver from the high power signals, and it is going to be multiplying the signals with the equal power levels, and then it is going to be down converter converts the RF signals into the IF signals. Okay, and these IF signals are demodulated and demultiplexed as necessary to generate the original baseband signal. That means this can be the IF signals are modeled and demultiplexing can be done in GCE, that is ground communication equipment. Okay, so in that it can be done. So whenever we are having the ground communication equipment, it is divided into two parts, it is transmitting and receiver. So these IF signals and demodulation is going to be done in our GCE receivers section. Okay, so that can be done with this. And the next one is power subsystem. Okay, so I have said that for any communication equipment or any electronic device, we require an power systems. So like that, in this also the earth station, it is requiring some AC sources. Not only with that, if any power is having some failures, so in that conditions also we are going to be using a AC generator that will look after. That means whenever the power goes, the generator automatically it is going to be starts the diesel engine and the smaller systems which can use the UPS, and that are going to be drives with this batteries. Okay, so power subsystem is very useful. Why? Because in order to have run all of the sections in our earth stations, we require an power subsystem. Okay, so this is about the earth station block diagram, each block. Okay, so I have explained the each block of our earth station. So the question we have a quiz on shortly, we are having some satellite based. So what is the first question means? India's first domestic geostationary satellite INSAT 1A was launched on 10th April 1982 from So India's first domestic geostationary satellite INSAT 1A was launched on 10th April 1982, which is from which area? That is, the first option is USSR, that is Russia, and the second one is USA, that is America, and the third one is United Kingdom, and the last option is UP. So what is an option is going to be right? That means India's first domestic geostationary satellite INSAT 1A was launched on 10th April 1982 from which area? Okay, so please note this question. So India's first domestic geostationary satellite INSAT 1A was launched on 10th April 1982 from which area? That is, the options are, the first option is USSR, and the second option is USA, and the third option is UK, and the last option is UP. So from which area it is going to be launched? The first domestic geostationary satellite, that is going to be calling as INSAT 1A. Okay, so it was launched on 10th April 1982. So what is an answer? So that is USA, that is B option is going to be the correct answer. From the USA, on 10th April 1982, the first India's domestic geostationary satellite was launched, calling as INSAT 1A. Okay, this is an answer. And the next question is, so a satellite signal transmitted from a satellite transponder to the earth station is going to be calling as, a satellite signal transmitted from a satellite transponder to the earth station is known as. So the options are, the first option is uplink, the second option is downlink, the third option is terrestrial, the fourth option is earthbound. So what is an option is going to be correct? That means a satellite signal transmitted from a satellite transponder to the earth station is going to be known as. Okay, so the first option is uplink, second option is downlink, third one is terrestrial, and the fourth option is earthbound. So please note this question. A satellite signal transmitted from a satellite transponder to the earth station is going to be calling as, the first option is uplink, the second option is downlink, the third option is terrestrial, and the fourth option is earthbound. So what is an option? Please see the answer. That is downlink. Why? Because a satellite signal transmitting from a satellite transponder, that means from the satellite it is going to be sending some signals towards the earth station, is going to be calling as downlink frequency of signal, that is going to be calling as downlink. Okay, that is an answer. So when we are having some signal transmitting from earth station to the satellite transponder, that signal is going to be calling as uplink. Okay, so whenever the signal passing from earth station to satellite is going to be calling as uplink, and whenever the signal transmitting from satellite to earth station is going to be calling as downlink. Okay, so this is an correct answer. And the next question, a satellite beam that covers almost 42.4% of the earth's surface is to be calling as, the first, that means a satellite beam that covers almost 42.4% of the earth's surface is known as. So the first option is zone beam, and the second one option is hemisphere beam, and the third one is spot beam, and the fourth one is global beam. So what type of satellite beam is going to be calling as when we are covering from 42% is going to be covered with our earth's surface? Okay, what is going to be calling? So the first option is zone beam, and the second option is hemispheric beam, and the third one is spot beam, and the fourth one is global beam. Okay, so what is an answer? Please note this question. So, a satellite beam that covers almost 42.4% of the Earth's surface is going to be known as, the first option is zone beam, and the second option is hemispheric beam, and third option is spot beam, and the last option is global beam. So, what is an correct answer? That is D. Why? Because the name already indicates that it is a global beam. Okay, so whenever it is covering the 42.4% of the Earth's surface, that beam is going to be calling as global beam. That means a satellite beam that is covering almost 42.4% of the Earth's surface is going to be known as global beam is the correct answer. Next question. A transponder is a satellite equipment which what it does. That means I have said in the previous session that what is a transponder does in our satellite. So the first one is it receives a signals from the earth station and amplifies. It changes the frequency of the received signal and it retransmits the received signal and does all of the above mentioned functions. That means a transponder is a satellite equipment which will receive a signals from earth station and amplifies and which will changes the frequency of the received signal or which will retransmit the received signal and does all of the mentioned above. So what is the correct answer? So first of all, note this question please. So a transponder is a satellite equipment which will, the first option is receives a signal from earth station and amplifies, and the second option is changes the frequency of the received signal. The third option is it will retransmit the received signal, and the fourth option is does all of the above mentioned functions. So what it does? So see the answer. That is D. Does all of the above mentioned functions. That means a transponder is a satellite equipment which will be receiving the signal from the earth station and amplifies it, that received signal, and it is also going to be changes the frequency of the received signal. Why? Because we are having some number of converting signals, that is we are having the mixture circuit, that is a single conversion, double conversion and regenerative conversion systems. In that we are going to be converting the signal strength also, that is from the 6 gigahertz it is going to be converted to 4 gigahertz in our C band. Okay, so in our microwave frequency ranges in the C band, in that we are going to be using them 6 gigahertz for our uplink frequency, and in the downlink frequency it is going to be converted to 4 gigahertz. That 4 gigahertz can be converted by the transponder. That means it will be changes the frequency of the received signal, and is also having the retransmission of the received signal. Why? Because whenever it is going to be transmitted to 4 gigahertz, that is going to be retransmitted to the earth station. So that means does all of the mentioned above functions. Okay, so this is an correct answer when we are having a transponder. Clear? Next question. A geosynchronous satellite. The option A, it has same period of that the earth. Second option, it has circular orbit. The third option, it will rotate in the equatorial plane, and the D option is has all of the above. Okay, that means a geosynchronous satellite is also going to be calling as geostationary satellite. Both are same, where a geosynchronous satellite is nothing but a geostationary satellite also. So that means this question is a geosynchronous satellite, what it does. That means what the function is going to be involved in our geosynchronous satellite. That is nothing but a geostationary satellite. So the first option is it has the same period of that of a earth, and it has circular orbit, or it having the rotating in the equatorial plane, or it is having all of the above. So what is an answer? First of all, we have to note this question, please. So, a geosynchronous satellite is also called as a geostationary satellite, and what it does means, the first option is it has the same period of that of a Earth, and the second option is it has circular orbit, and the third option is which will be rotating in the equatorial plane, or the last option is that is has all of the above. So, what is the correct answer? That is D. That means a geosynchronous satellite is having the same period of that of the earth, and is also having the circular orbit, and it is rotating in the equatorial plane. So all it does is going to be done with the geosynchronous satellite. That means a geosynchronous satellite is also called as geostationary satellite. Okay, so in the previous session I have told that why it is going to be calling as geosynchronous satellite means the velocity of the satellite moving is going to be same as that of the earth. That means the period is going to be 24 hours for earth, and at the same time the satellite is also having the period of 24 hours. So it is both. So whenever a person standing on the earth curvature, when it is going to be observing that satellite, which will be appearing as a stationary. Why? Because the earth is also rotating, at the same time the satellite is also going to be rotating. So whenever the two bodies are going to be moving particles, that will be having the same motion. So that means the two bodies are going to be appearing as stationary. Okay, so like that the geosynchronous satellite or geostationary satellite is going to be called. That means a person which is standing on the earth's curvature, when it is going to be observing that satellite, so that satellite is going to be appearing as stationary. Okay, so for that reasons we are going to be calling as geostationary satellite. So this is an answer. So in this session I have covered the earth station block diagram, and I have explained the each block of our earth station. Okay, so why we are needing of earth station means this the what is the main need of earth station means, which is going to be used for transmitting the information to the satellite, and it is also used to receive the information from the satellite. Okay, so there is a main use of earth station. Okay, so whenever we are having the satellite usage or satellite communication above the earth curvature, whenever we are placing some satellite, in the satellite the internal part of the satellite is the transponder, and we have learned that what is a transponder and what are the main blocks which are going to be involved in the transponder is going to be seen in the previous sessions. And whenever we are having the satellite communication, the main parts of satellite communication is data, earth station and satellite. Okay, so whenever we are having the satellite, in that we have seen whenever we are having the satellite, we are seen with the communications satellite, and whenever we are having in the on the ground, we have to seen with the earth station also. So for these reasons we have seen about the earth station, and in our earth station we are having number of blocks that are ground communication equipment, transmit subsystem, antenna subsystem, receive subsystem, power subsystem. So the each block having a single blocks, that is in a single process which is to be done with this earth station. Okay, so I have said about the block diagram also, and I have said the operation of each block. Why? Because it is having number of blocks, that is which are having 5 blocks mainly, that is ground communication equipment, and it is going to be divided into two parts, it is transmitter and receiver. And in the transmit subsystem, which is consisting of up converter, power amplifier, combiner, BPF. Okay, and not only with that, we are having the antenna subsystem. In that we are having the duplexer, and in the receive subsystem we are having the down converter, BPF, local oscillator, and low noise amplifier. Like this we are having all of the blocks within this. So I have explained in this. Okay, so thank you.